Okay, so here's where section 2.2 would begin. A couple of terms to talk about first thing. The universal set for a given situation, which is denoted by a capital U, is the set of all objects that are reasonable to consider for that situation. In set theory, it is sometimes helpful to visualize a Venn diagram. We're going to be working with Venn diagrams quite a bit in the next two sections especially. A Venn diagram is a picture that illustrates the relationship between one or more sets in the universal set. The rectangle represents the universal set, and each circle represents a set of interest inside the universal set. Okay, so another definition for any set A, the universal set U. The complement of A, denoted by A complement is how we read that symbol, is the set of all elements in the universal set that are not in A. Okay. Some books use a capital C in the upper right-hand corner. Some books use a dash, so this one uses a dash. Problem 18, I'm going to shade the region on the Venn diagram that represents A complement. Okay, so here's the universal set. Here's set A. The complement of A is all the elements that are in the universal set but outside of set A. Okay, so I would shade everywhere outside of set A, and that shaded region there is A complement. Problem 19, I got the universal set, which is the letters that consist of A through H, and then set M and set N. Write down the following sets. So M complement would be the set of all elements that are in the universe, but not in M. Okay, so let's see, anything not in M, but still part of the universe, which should be the set containing B, C, F, G, and H. Okay. N complement is the set of all elements in the universal set that are not in N. Okay, so that'd be the set containing A, C, and G is not in N. Okay, so that'd be an N complement. The universal set, the complement of that, is the empty set. So the opposite of a set with everything in it is to have a set with nothing in it. Part D, the complement of the empty set is the universal set. So the opposite of a set with nothing in it is to have a set with everything in it for that problem, which is the universal set. Now the universal set is going to change from problem to problem, so we've always got to make sure that we know what the universal set is for that problem. Okay. Here's a definition. It says if every element in a set A is also in a set B, then we say that A is a subset of B. And we write, here's the symbol that we use for a subset. So A is a subset of B. A Venn diagram showing A is a subset of B is shown below. So every element in A is also seen in B. Okay? So A would be a subset of B. Problem 20, fill each blank with either the subset sign or not a subset sign to make each statement true. Okay, so part A, I got the set containing 2, 5, and 8, which is a subset of the set containing 2, 5, 8, 11, and 14. Yeah, that's true, because all the elements that I see on the left can be seen in the set on the right. Okay, so the set on the left is a subset of the set on the right. Now, if I switch the two sides, which I've done in part B, then, okay, I don't see 11 or 14 listed there on the right, so the set on the left is not a subset of the set on the right. Okay? Remember, with set notation, you can mix up the elements as long as you've got them all, and it's not going to matter. Okay, so in part C, I got the set containing 5, 6, 7, and 8, which is a subset of the set containing 6, 5, 8, and 7. Yeah, that's true. Since every element is seen in the set here on the right. In other words, part C, any set is going to always be a subset of itself. Okay, and that's all we're saying there in part C. Part D, the empty set is a subset of the set containing 3, 7, and 9. So the empty set is a subset of any set. Okay, since you can't give me an element in the empty set, because the empty set has nothing in it, then by default, okay, the set on the left is a subset of the set on the right. Okay, the empty set is always going to be a subset of any set. Okay, because of the definition here. So you can't give me an element in the empty set. The empty set has nothing in it. Okay, that you don't also see in the set on the right, and that's what we could do in like part B, for example. Okay, now switching the two sides matters here, and in part E, I got the empty set is a subset of the set containing 0. Yeah, the empty set is a subset of any set. Okay, I just said that. So yeah, that's gonna be true. Part F. The set containing 0 is not a subset of the empty set. So yeah, I don't see the set containing 0 in the empty set. So the empty set has nothing in it, right? So to say 0 would be in there would be not true. Okay. Part G, you got the set containing 1/2, 1/3, and 3 is a subset of the set containing all x, such that x is a rational number. Yeah, that's true. So 1/2, 1/3, and 3/1 are all examples of rational numbers. So those three elements would be seen in the bigger set, which is the set of all rational numbers. Okay. Part H, the set containing lowercase a, lowercase n, lowercase d, lowercase y, is not a subset of the set containing capital R, capital A, capital N, capital D, capital Y. Yeah, so I don't see a lowercase a listed anywhere in the set on the right, or any lowercase letters for that matter. So the set on the left is not going to be a subset of the set on the right. Definition: set A is a proper subset of set B if, number one, A is a subset of B, that has to be true, and number two, A is not equal to B. So A can't be equal to B, okay, for the case of a proper subset, okay. To write a proper subset sign, you write the subset sign but don't have like the equal sign underneath is kind of the best that I can explain it. Okay, so the way that I'd read this is to say A is a proper subset of B. Problem 21, decide whether the subset sign, the proper subset sign, both or neither can be placed in each blank to make a true statement. Okay, so part A. Well, both of these signs are going to work. So the set on the left is a subset of the set on the right, since the elements 2, 5, and 8 can be seen on the set on the right, and they're not the same set. Okay, so I could use both if I wanted to. I could use the subset sign or the proper subset sign. Either one is going to work. Now in part B, I got the set containing 2, 5, and 8 on the left, and then the set containing 2, 5, and 8 on the right. So the only condition for a proper subset is that A cannot be equal to B. Well, here A and B are the same thing, and so you cannot use the proper subset sign. Okay, only the regular subset sign can be used. And by the way, any set is always a subset of itself. Okay, that is a true statement. Part C, the empty set is a subset of any set, right? The empty set would always be a proper subset of any set as long as the other set is not the empty set, because otherwise you have the same set, Okay, so in part D, I can't use the proper subset sign. Okay, I would be forced to use the subset sign. Okay. Part E, I got the set containing 5/6 and 9/8, and the set containing 6/5 and 8/9. Well, that's going to be neither, since 5/6 is not seen in the bigger set, or the other set, I should say. So it's not a subset. It's not a proper subset either, since these two are not the same. These are not equal to each other, or a subset to begin with. Part F, I got the set containing capital I, capital C, and capital C. That is a subset of the set containing capital I and capital C. Yeah, so one thing that I mentioned about sets is that you can repeat an element as many times as you want. Okay, so like if I wanted to repeat the element C 23 times, I could do that. I would still only count that as one that is different from the others. Okay, now these are not a proper subset, so the set on the left is not a proper subset of the set on the right, since these two sets are equal to each other. Okay, and you cannot have A equal to B for a proper subset. Okay. Problem 22, list all the subsets of the set containing 3 and 4. Okay, so the empty set is a subset of any set. That's always the first one that I list. The set containing 3 is a subset of the set containing 3 and 4. The set containing 4 is a subset of the set containing 3 and 4. And then any set is always going to be a subset of itself. So the set containing 3 and 4 is going to be a subset of the set containing 3 and 4. Okay. Problem 23, list all the subsets of the set containing little j, little o, little e. Okay, well the empty set is always a subset of any set. The empty set, again, is always the set that I list first. You don't need to do it like that, but since the empty set is always going to be a subset of any set, that's, I always list that first. The set containing j, the set containing o, and the set containing e are all subsets of the set containing j and o and e. The set containing j and o. Now, what about if I had the set containing o and j? Well, that's not any different from this set, right? So that's one thing that we've talked about already, is that with sets, order doesn't matter, right? So the fact is that I've got the same set here listed. It doesn't matter the order of the elements. Okay, so I don't need to list the set containing o and j. I've already got that listed. There's the set containing j and e. There's the set containing o and e. And then the set containing j and o and e. Okay, so there should be 8 sets, I think, total. Problem 24 is a fact saying that the number of subsets of a set with n different elements is 2 to the n power. If a set contains n different elements, how many proper subsets would there be? Well, a proper subset is just where you're doing exactly the same thing. The only one that you're not including is the actual set itself. Okay, so A can't be equal to B. So whatever 2 to the n ends up being, subtract that one possibility where you end up listing the same set. Okay, if you're going to talk about proper subsets. So as an example, a couple of examples here. Problem 25, how many subsets can be listed from the set containing all the days of the week? Well, there's 7 days in a week, right? So 2 to the n, 2 to the 7th, would be 128 subsets that I'd list. Okay. Problem 26, how many proper subsets can be listed from the set below? So the set containing Lake Erie, Lake Huron, Lake Michigan, Lake Superior, and Lake Ontario. Okay, there'd be 32 subsets. Now that's not what they're asking for. They're asking for proper subsets. So proper subset is where I disregard the set containing Lake Erie, Lake Huron, Lake Michigan, Lake Superior, and Lake Ontario. That's the only set. So there'd be 31 proper subsets. Okay. Problem 27, how many subsets can be listed from the set containing LOL? Okay, so I guess the first question is how many elements are in this set? There'd be 2, not 3. Okay, so again, you can repeat an element as many times as you want. You're only going to count that as one that is different from the others, though. So this is a set with 2 elements in it. 2 squared, there'd be 4 subsets that can be listed. Okay, and here's 4 is not too many, so I went ahead and list them. The empty set is a subset of any set, the set containing capital L, the set containing capital O, and the set containing capital L and capital O. Okay. Problem 28, suppose that a jar contains 1 penny, 1 nickel, 1 dime, and 1 quarter. If you must select at least 1 coin, and you may select up to all of the coins, how many different sums of money can you make? Okay, so here's an example of subsets. So I have to select at least 1 coin. Okay, I could select 2 coins if I wanted. I could select 3 coins. I could select all 4 coins if I wanted. I have to select at least 1, though. So this is asking for the number of subsets in a set with 4 elements in it. Okay, a 1 penny, 1 nickel, 1 dime, 1 quarter. That's 4. 2 to the 4th would be 16 subsets. Now, since I have to select a coin, okay, that does not include the empty set, okay, the empty set would be where I'd select nothing, okay, there'd be 15 sums of money that I could make, okay, so, okay, if I were to allowed to select, anything, including nothing, then there'd be 16 sums of money that I could make, okay, so since there's 16 subsets, that includes the set containing $0, okay? So, but I'm disregarding that with the empty set there. The homework in this section is on page 60. Be sure to look at those problems when you get a chance.